On March 24, 1945, near the town of Wesel, Germany, Lieutenant General William H. Simpson watched one of the most ambitious river crossing operations of the Second World War unfold before him. The Rhine River lay ahead, a massive natural barrier that German planners had long viewed as the final shield protecting the heart of Germany. For years, military strategists across Europe had understood a simple truth. Rivers could stop armies. Bridges could be demolished. Crossing points could be defended. Entire offensives could grind to a halt at the water's edge. Yet something extraordinary was about to happen. As Allied troops pushed toward the eastern bank, American engineer units moved in behind them. German observers expected days of delay. They expected traffic jams, shortages, confusion, and vulnerability. Instead, they witnessed a process that seemed almost impossible. Sections of floating bridge appeared on the river with remarkable speed. Piece by piece, what had been a major obstacle was transformed into a functioning highway for tanks, trucks, artillery, and supplies. For German engineers studying the battlefield, the shock was not simply that the Americans had built bridges. Armies had built pontoon bridges for centuries. The real surprise was how quickly, how reliably, and how repeatedly they could do it. This documentary is the story of those floating bridges and the larger system behind them. It is a story not just about engineering, but about logistics, industrial production, organization, and military doctrine. It reveals how American engineer units helped maintain the momentum of the Allied advance, and why some German specialists came to see these bridges as far more than temporary structures. Because the true secret was not floating on the water itself. It was hidden inside the vast machine that made those bridges possible. For centuries, rivers had been among the most effective defensive barriers in warfare. Mountains could be bypassed, and fortifications could be bombarded. But a major river presented a unique challenge. An attacking army had to move thousands of men, vehicles, guns, and tons of supplies across a narrow crossing point while exposed to enemy fire. If the defenders destroyed the bridges first, the entire offensive could stall. German military planners understood this reality better than most. During the Second World War, the German army repeatedly used rivers as defensive lines, forcing opponents to conduct costly and time-consuming crossing operations. Every destroyed bridge bought precious time. Every delayed crossing allowed reserves to arrive and defensive positions to be strengthened. The Allies encountered this problem throughout their advance across Western Europe in 1944. After the breakout from Normandy, following Operation Cobra, Allied armies moved faster than many commanders had anticipated. But speed created a new challenge. The further the armies advanced, the more rivers they encountered. The Seine, the Meuse, the Moselle, and eventually the Rhine all stood in the path of the Allied drive toward Germany. Each river crossing posed the same question. Could the advance maintain momentum, or would it slow long enough for German forces to recover? German commanders increasingly relied on natural obstacles to compensate for their deteriorating military position. By late 1944, fuel shortages, manpower losses, and Allied air superiority made large-scale counterattacks difficult. Rivers became some of the few defensive assets still available. If bridges could be destroyed faster than the Allies could replace them, entire offensives might be delayed. But the Americans approached the problem differently. Rather than viewing rivers as major operational pauses, they developed systems designed to cross them quickly and repeatedly. Specialized engineer units trained specifically for this task. Equipment was standardized. Procedures were refined. Materials were produced in enormous quantities. The result was a capability that would soon surprise even experienced German engineers, because America's floating bridges were only the visible part of a much larger engineering revolution. Long before Allied troops reached the rivers of France and Germany, American military planners had been preparing for a problem they knew would eventually emerge. Modern mechanized warfare depended on movement. Tanks, trucks, fuel convoys, artillery batteries, and supply columns could not afford to wait for permanent bridges to be repaired. If the advance was to continue, the army needed a way to create bridges wherever they were required. The solution came from a combination of engineering innovation and industrial scale. The U.S. Army Corps of Engineers developed standardized pontoon bridge systems that could be transported in sections, assembled rapidly, and adapted to different river conditions. Unlike many earlier military bridges, these designs emphasized speed, flexibility, and compatibility with heavy vehicles. Components were manufactured to common specifications, allowing engineer units to replace damaged sections and expand crossings without lengthy redesigns. Equally important was the organization behind the equipment. Dedicated engineer combat battalions, trained extensively in bridge construction, river reconnaissance, and combat crossing operations. These units practiced assembling pontoons under difficult conditions, often working at night or under simulated enemy fire. By the time they entered combat in Europe, many crews could perform tasks with remarkable efficiency because every soldier understood his specific role. America's industrial capacity transformed these engineering concepts into reality. Factories across the United States produced vast quantities of bridge sections, boats, anchors, cables, decking, and support equipment. When engineer units requested materials, an enormous logistical network stood behind them. The bridge appearing on a riverbank was only the final link in a chain that stretched back thousands of miles to American factories and ports. This system gave Allied commanders a significant advantage. A destroyed bridge no longer guaranteed a lengthy delay. In many cases, engineer units could begin constructing replacements almost immediately, reducing the time defenders had to reorganize. German engineers observing these operations increasingly realized that they were confronting something larger than a clever bridge design. They were witnessing an entire military system built around sustaining momentum. And nowhere would that advantage become more visible than during the Allied race across France and toward Germany's borders. The summer of 1944 marked a dramatic turning point in the war in Western Europe. Following the success of Operation Cobra, Allied forces surged across France at a pace that surprised even some of their own commanders. German formations were retreating, roads were crowded with military traffic, and every day of momentum increased pressure on a weakening German defense. But rapid advances created a dangerous vulnerability. Armored divisions could move only as fast as their supply lines. Tanks needed fuel, artillery needed ammunition, and troops needed food. Rivers threatened to interrupt that flow. German engineers destroyed bridges wherever possible, hoping to force Allied armies into lengthy pauses that would allow defensive lines to stabilize. Instead, American engineer units repeatedly prevented those pauses from occurring. As Allied forces approached the Seine River in August 1944, engineer battalions moved forward alongside combat formations. Temporary bridges appeared across the river soon after crossing sites were secured. Trucks loaded with fuel and ammunition began moving eastward, helping sustain the advance. Similar scenes unfolded at numerous rivers and canals throughout France and Belgium. While individual crossings varied in difficulty, the overall pattern remained remarkably consistent. Obstacles that German planners expected to slow the Allies were overcome with surprising speed. The effect of German operational planning was significant. Defensive calculations often assumed that major rivers would provide time to regroup, move reinforcements, establish artillery positions, and organize counterattacks. Yet, American bridging operations repeatedly reduced that window. A river that might once have delayed an army for days could sometimes be crossed in a fraction of that time. What impressed observers was not merely the construction itself, but the consistency. Engineer units carried out these tasks again and again across different terrain, weather conditions, and combat situations. Their success reflected training, logistics, standardized equipment, and command coordination working together as a single system. By early 1945, German leaders knew the final confrontation was approaching. One river remained above all others in their calculations: the Rhine. There, America's floating bridges would face their greatest challenge and prove their greatest value. By early 1945, the Rhine River had become the last great natural barrier protecting the core of Nazi Germany. Stretching across the path of the advancing Allied armies, it was more than a geographical obstacle. In German military thinking, the Rhine represented a defensive line that could slow the Allied advance long enough to prolong the war and perhaps create opportunities for political or military change. Then, on March 7, 1945, an unexpected opportunity emerged. Soldiers of the 9th Armored Division captured the Ludendorff Bridge at Remagen before German demolition teams could fully destroy it. The event shocked both Allied and German commanders. For the first time, Allied forces had secured a major crossing over the Rhine. Yet the famous bridge at Remagen was only the beginning of the story. German artillery, aircraft, and demolition damage continuously threatened the structure. Allied commanders understood that relying on a single bridge was too risky. Engineer units immediately began constructing additional crossings. Floating pontoon bridges, treadway bridges, and ferry systems appeared around the area, ensuring that troops and supplies could continue moving even if the damaged bridge became unusable. When the Ludendorff Bridge finally collapsed on March 17, the broader crossing operation did not collapse with it. American engineers had already created alternatives. This was precisely the kind of redundancy that German planners found difficult to counter. Destroying one crossing no longer guaranteed success because several others could quickly take its place. Later that month, during Operation Plunder, Allied forces launched massive crossings farther north. Engineer units worked around the clock, often under difficult conditions, assembling floating bridges capable of carrying tanks, artillery, and endless streams of vehicles. Within days, enormous Allied forces were operating east of the Rhine. For German engineers watching the campaign unfold, the lesson was unmistakable. The Rhine had been expected to delay the Allies significantly. Instead, it became another obstacle that American engineering and logistics managed to overcome. But the most revealing question remained unanswered. Why did German engineers consider these bridges so extraordinary in the first place? When German engineers analyzed Allied operations during and after the war, many reached a conclusion that extended far beyond the bridges themselves. The floating bridges were impressive, but they were merely the most visible part of a much larger advantage. What truly stood out was the system that allowed those bridges to appear exactly where they were needed, often at remarkable speed. German military engineering was highly skilled and capable of producing sophisticated solutions. Throughout the war, German engineers constructed defensive fortifications, repaired transportation networks, and supported complex military operations across Europe. However, by 1944 and 1945, Germany faced mounting shortages of fuel, raw materials, transportation capacity, and trained personnel. Even the best engineering plans became difficult to execute when resources were increasingly scarce. The Americans operated under very different conditions. Engineer units did not function in isolation. They were integrated into a vast logistical network that linked frontline formations to ports, railways, depots, factories, and shipping routes stretching across the Atlantic. When a bridge was required, equipment, vehicles, replacement parts, and trained personnel were usually available in the quantities needed to complete the mission. Standardization played a critical role. American bridge components were designed to work together efficiently, reducing delays caused by incompatible equipment. Training programs ensured that engineer units followed established procedures. Commanders understood how to employ these units, and supply organizations knew how to support them. The result was a level of operational consistency that impressed even experienced German observers. Post-war analyses repeatedly highlighted a broader reality. Allied success depended not only on superior firepower, but also on superior mobility. A river crossing was not simply an engineering task. It was a test of planning, production, transportation, communications, and leadership. The United States excelled in combining all of these elements into a unified system. German engineers recognized that reality. The floating bridges changed the battlefield because they reduced the effectiveness of one of Germany's most reliable defensive tools. And in doing so, they revealed a truth that extended far beyond any single river crossing. When people think about the Allied victory in Europe, they often remember the tanks, the aircraft, and the dramatic battles that filled newspaper headlines. Yet some of the most important weapons of the war were far less glamorous. They were built from steel, pontoons, cables, and wooden decking, assembled by engineer units working under pressure to keep entire armies moving. America's floating bridges did more than carry vehicles across rivers, they carried momentum. Every successful crossing reduced the value of Germany's natural defenses. Every bridge completed ahead of schedule denied German commanders the time they desperately needed to reorganize their forces. What impressed German engineers was not a single bridge or a single operation. It was the combination of industrial production, standardized equipment, specialized training, logistical support, and organizational efficiency working together on a massive scale. The bridge visible on the river was only the final product of a system that stretched from American factories to the front lines of Europe. By 1945, that system allowed Allied armies to cross rivers that had once been considered major military obstacles. The Rhine, the last great defensive barrier of Nazi Germany, ultimately failed to stop the advance. In the end, the story of America's floating bridges is not simply an engineering story. It is a story about how logistics became a weapon, how organization became combat power, and how a hidden capability helped accelerate the collapse of the Third Reich. Sometimes the course of history is changed not by the weapons that destroy, but by the bridges that allow an army to keep moving.